Hi, I'm Peter Nobick from STAC, president of STAC. I realize I'm in the unenviable position of being between you and drinks, so I'm going to try to make this, if not interesting, I'll make it brief. So first off, we'll start answering some questions. Who am I? Just quickly, my background. I spent 10 years at a high-performance trading or high-frequency trading company in Chicago, Alston Trading, where I had a variety of jobs, including CTO, building out low-latency systems, but also high-performance data analytics systems. Back at a time when we thought that we had to build it ourselves to have edge, we wasted a lot of time building things that vendors provide for us now. I also spent some time in the US Treasuries market, so I'm very personally interested in May 31st, June 1st coming up to see what happens to the marketplaces then. One thing I constantly hear from now that I spend time speaking to over 400 different financial firms on a fairly regular basis, I constantly hear our systems can't handle all the volatility when it spikes, like that day we saw in the previous presentation, right? Was that March 12th? Might see that again. It'll be interesting to see what data analytics systems and real-time trading does then. But 3 years ago, I joined STAC as president of STAC. If any of you know the other Peter Langford, we like Peters, just like KX likes Connors. There's now been 2 leaders of the company, both with the same name. And what is STAC? For those of you who don't know STAC, we're the Securities Technology Analysis Center. Our goal is to provide insight for the algorithmic enterprise, but what that really means is we're trying to help people with technology discovery, to figure out what the right technology platforms are for them. We focus on full stack technology platforms. We have a strong belief that if you're not looking at the full stack, if you're not looking at the full solution set for a given problem, you're missing bottlenecks, you're missing performance issues. You might maximize performance in one place just to make it actually worse overall if you're not looking at the full thing. We also coordinate the STAC Benchmark Council. We'll get to what that is in a second. But in order to talk about the discovery and assessment of technology, and it's primarily in the finance industry, though what we do in finance, we are finding does not exist in a lot of other industries. And so we're actually having other industries now come to us and ask us to do similar for them. So it might not be just finance for long. But we do research and dialogue. And what research means is STAC reports. We do full audits of systems. Vendors will bring to us optimized versions of their systems to solve different problems. We will then do audits of those as a completely independent third party. One of the things that proves we're completely independent and neutral on this is a number I can't really cite, but is the number of times that a vendor does not do an audit because they don't like the results and they can't convince us to cut half of the tests out of the results. Why don't you let us change configurations between each query we run? Well, because what financial firm is going to take down their entire system at 9:30 in the morning and change the configuration because they think 9:31 might be different, right? You have to have the same system, the same configuration. But we do vault reports. We also do independent research where we will look at new problems and new issues in the industry. And then we also foster dialogue. We have working groups, special interest groups, and we have STAC events. If the next roughly 15 minutes of my talk does not cause you to drink more at cocktails tonight, then come join us at May 31st in New York, where we're going to have an event where we don't just talk about tick analytics and time series data, but talk about everything STAC does. So what is the STAC Benchmark Council? It's 400 plus financial firms and 50 plus, it's actually closer to 60 over the last month. Leading technology vendors. And what we do is we don't just have discussion, but we actually develop and design benchmarks. So STAC does audits, right? We have benchmarks and specifications that people have to develop to. It's very important for you to know that these are not STAC in an ivory tower creating these and saying this is what finance wants. STAC benchmarks are developed by financial firms for financial firms. Vendors contribute to the discussion. When push comes to shove, only financial firms have a vote. Only financial firms have a say as to what we're actually benchmarking, what are the workloads, and how do we take the measurements, and then what comparisons do we allow. So that's all done in the Stack Benchmark Council. We have different working groups. The Stack Benchmark Council now has, I think, 9 different domains. It's kind of split in two. We have historical analytics, and we have real-time decision-making. So real-time decision-making is everything from tick-to-trade benchmarks, full network stack benchmarks, time stamping, and time synchronization benchmarks. And on the analytics side, we have high-performance compute with derivatives risk calculations. We have backtesting, and most important to the conversation today, we have STAC-M3, which is our tick history analytics. So what is STAC-M3? And I think this might be the last question we'll go through. It's performance benchmarks for tick analytics. It was developed by banks and hedge funds. There were a couple of proprietary trading firms on the periphery, but now they mostly use it as well, even though they weren't involved in the development. It does measure performance of the full stack. So this isn't just looking at a time series database or a database that can do time series. It's not just looking at compute. It's not just looking at memory or storage. It is everything. It is the entire system put together. So it's what your quants might be using in their day-to-day, right? So it's measuring that whole soup to nuts. The workload is based on synthetic data modeled on NICE TAC. We use synthetic data for 2 reasons. One, that way no one has to pay exorbitant licensing fees in order to test and to use this. And 2, it allows us to control the data more so that we can have unique data from test to test, but make sure that the workloads tested each time are comparable so that you don't have one person showing fantastic results because they got lucky with the data set. We also simulate concurrent access by varying the number of users. So STAC-M3 has a number of queries where 1 runs at a time and has some where 10, 100, 500 queries are running at a time, simulating multiple users across a firm accessing the database at once. And we have a mix of I/O and compute-intensive operations. So we have multiple suites in STAC-M3. We have our baseline, which is Antuco. It's 1 year of data, although we do some things in this data set to simulate a bigger data set. For example, between a lot of the queries, we require caches to be flush and systems to be reset so that you're pretty much always looking at like somebody getting performance without data being loaded into memory or into cache. We have Shasta, which is basically Antuco but in memory. It's in memory, and I would say as a service now, because the rules of Antuco basically the rules of Shasta are basically the same as Antuco. By the way, these are all volcanoes. I don't know why. That predates my time, but if you're wondering where these names came from. But if you're using a database as a service or you're in a memory database, there's no restart. You're not going to have Google restart BigQuery for you. You're not going to be able to do any as-a-service database in Amazon and have them restart it for you. So Shasta is Antuco, but without the restarts, without the cache flush. And then we have Scale, which is Kanaga. For Kanaga, you can scale to as many years as you want. There are some storage vendors talking about showing how they can scale to 20 years. It would be great if they actually run those benchmarks. I would love to see what happens when they put 20 years of data on the system. But most people do 5 years of data. That tends to be the set. If you're ever looking at stack benchmark reports, you can assume 5 years unless it tells you otherwise. And then finally, we have our streaming benchmark, which is Jalua. That has a variety of workloads as well. The first implementations of that, I think, are underway. I say, trying to shame KX into doing it. And it'll be interesting to start seeing some real-time systems published, reports published on that. So we have scores of different results on different architectures. There's about I think 9 years worth of results. There are many reports done per year. It is a wide range of implementations. We have multiple databases that have run this. I will say KDB Plus is used in the majority of the tested stacks. People looking to showcase their performance have showcased the performance of their hardware, have chosen KDB over other database implementations the majority of the time. We have clustered file systems, parallel file systems, NFS, flash arrays, NVMe over Fabric, NAND, post-NAND, right? There's a whole number of them on Optane, which I guess is no longer applicable going forward, but we're going to touch on those in a bit as well. single database server, database clusters, bare metal, virtualized containers. The list goes on. And for every stack report, there's also a detailed configuration disclosure. So if you wanted to replicate the exact setup that they did in order to get the performance they got, you can do that. So why are there multiple architectures? It's primarily because there's multiple use cases for tick data in finance. I know a lot of you out there, I'm probably preaching to the choir, but for those of you who don't, I think of it as breaking down into kind of three major categories of use cases. The first is known load or known set of workload, what you're running at night, or somebody has already researched a system, a signal they're looking for, and now you're going to run that over the course of time over many, many asset classes, many days, but you know the workload. You know how much compute you're going to be taking up. You know how much data you need. The other is ad hoc research. This is oftentimes, I think of this as like a scratch data set. You've got a quant, you want to give them a really high performance system, you're going to give them 6 months of treasuries data, you're going to give them a month of equities data, you're giving them a year of treasuries, whatever it may be. This is your squeaky wheel person, right? The person who no matter what is going to complain about noisy neighbors. So you set them up with their own system and they're doing ad hoc research. The other use of ad hoc research, which is oftentimes overlooked, is if you have a good operational support desk that actually understands the impact of market conditions on technology, they're going to be doing a lot of ad hoc research too, because they're exploring the third category, and that's what the hell just happened. And I call it that category because it's when somebody is furiously looking at the market while their boss is standing behind them and not using the word hell, and repeating that question over and over again in ways that is not helpful. But you're searching through all that data and you're doing it on the fly. That is often the most recently ingested data. So for each of these use cases, there's different architectures. And so different hardware vendors will showcase their hardware in different ways for these, and often use KX across all of them. Multiple architectures, multiple uses, but they want standard interactions. Nobody wants to query the data one way for what the heck just happened, and then when you're trying to figure out, when you're running your long-term stuff, using a different query, using a whole different system, there's change risk involved in that, et cetera. So in STAC-M3, we've seen KDB across multiple system designs. They are part of more systems than systems under test or stacks under test than any other database that we've seen. They're used in a variety of these architectures. And in fact, I'm going to go into some of the most recent ones so you can see the diversity. So in the last couple of years, this was in 2022, Dell wanted to showcase their PowerScale F900 all-flash NAS, and they ran the baseline Antuco and Kanaga suites. Now, Dell was highlighting their ability to scale into larger data sets and to have more concurrent users running. They chose KDB 4.0 in distributed mode for that. This is the entire stack. For the interest of time, I won't read through the hardware, but you can go see that. You can also see the report at this link. If you don't have a Stack Research account, you'll have to create one to get access to the report, but it's free, and the terms and conditions basically just say you're not going to distribute the report yourself or claim that it's yours. So it's not all that onerous to get access. Right, so they ran this, and I seem to be missing a slide in there. Maybe it's on the first one. No, that's what Dell wanted to highlight. Oh, actually, this didn't set any records. That's why I don't have a record slide on here. But Dell wasn't trying to showcase that they could set records. They weren't trying to show that they had the best badass performance system out there. They're trying to show that they had one that could service the needs of what they were hearing from people, and that was cost-effective and able to scale out to many, many users. Now, DDN also recently ran, so this is another network-attached all-flash, and this one they ran with 16 database servers, so they're showing even more servers running KDB, connecting to the storage. This was another one that wanted to showcase scaling, and in fact, they were showcasing the performance of scaling to 2 DDN storage devices. There's a previous audit you can look at from a couple years before that where they only used one of the same storage device. Again, they had KDB. This one was interesting because they used 4.0 Cloud Edition in distributed mode. I think this was the first audit done with Cloud Edition. And And they did set a record. Compared to all other publicly disclosed mean response times, we typically cite the mean response times, but we show our reports have min, max, standard deviation, 99th percentile, et cetera. But this is across all the different queries. It dawns on me I never talked about what type of queries are on this. All of the queries, let's pause and go to that. All of the queries that we have were given or provided by financial institutions. It's the stuff that financial firms do enough on a daily basis where they can use the results of those queries as a reasonable proxy for the queries they wouldn't share with us. These queries don't just run on a day of data or an hour of data. Many of them run on 6 months, a month, 6 months, 9 months of data. There are some that just look at a day. There are some that look across a day, like you start at 10 at night and roll into the next day. We're talking queries like volume curves in BBO. So we have point in time where they're given 100 symbols and have to figure out, the query has to figure out rapidly what the national best bid and offer was across 12 different exchanges. So for a given time, which means they have to find that time and work backwards to get the right results. There's a whole number of volume-weighted average price queries, different statistics that get generated, and then simply pulling data. And then we have a couple of writes as well, write benchmarks. This set a record in 4 of the 700 user benchmarks. They wanted to show scale, they did that. And those are the exact indicators that they set them in. These were doing actually VWAB queries across 1, 2, 3 years of data. And they were also doing intervalized statistics. So we have an intervalized statistics query that looks at, for a given interval, calculates statistics on the market data. On-prem is not all, though. Recently, AWS wanted to showcase their IO2 block express storage and chose KDB for that. This was Amazon's first ever engineered STAC-M3 solution. We'd had other solutions done by other vendors on Amazon, but this was Amazon's first one. And they used 4.0 running in distributed mode. Again, you can see the whole stack they chose there. They had the fastest 10-user volume curve mean response time. So they set a record as well. At a similar time, Google did one. So another cloud-based stack under test. This one, though, is with distributed storage on the database servers themselves rather than using network-attached storage. And they use sharded mode. And they use 12 different nodes on KDB plus 4.0. They set a record in 16 of 24 of the Kanaga benchmarks. 7 of the 16 had speedups exceeding 2.2x compared to the previous best results. So they really highlighted that you can get good performance in the cloud and use KDB to do that. Now here's a more recent one. And at first I thought I would not even bother going into Optane results because it's been discontinued. How are you going to replicate this? But a lot of people have interest in having like a contained system that is as just blazingly fast as possible for that squeaky wheel quant or for those guys who just need to be as productive as possible, right? And so I wanted to go over this one on Optane memory, on PMEM. It ran both Antuco and Kanaga, so 60 TB of PMEM is a hell of a lot of Optane. But they did. This was the first SUT to run the full 5-year data set in persistent memory. By the way, it's not just a 5-year data set. To query 5 years of data, we actually require them to have, I think it's 11 years of data on there, just so that, put the database through its paces a little more, make sure that indexing actually works. So they set a number of records. Talking about the records of all those different SUTs, you'll notice that records are hard to come by. Like Dell had no records in the one they had. There was another one with only 1 record. And the reason for that is because there's fierce competition in this space. Also, different needs demand different architectures. It's rare that you have a SUT that comes out that sets a record in everything because they have to make trade-offs into what they want to optimize for and what they want to show that they're good in. There's So people will configure their SUTs differently to get different optimalities, and also many aren't always showcasing absolute performance. Now, if we go back and look at all the different queries or all the different reports that have been done and look through them, the SUT holding the record used KDB Plus as the database in 15 of 17 mean response time records for Antuco, and all 24 of the mean response time records for Kanaga. I don't have Jalua results because we don't have a KDB Jalua audit. That's just me dropping another hint. I didn't bother going into Shasta on this just because Antuco and Kanaga have been the most recently done audits. So I wanted to talk about the stuff that was kind of most hot of late. This is a breakdown. I know these screens are small and that's small type, but it'll be in the slides and I'm sure those are available at some point afterwards. This is a breakdown of the records they hold in the SUTs. And you can actually go to our website and stackresearch.com, and then the SUT ID is how you get directly to that report. So all of these you can look up. And I wanted to show that this for a few reasons. You can see a large variety of SUTs here, right? The storage, like if you look at the total cores used in these, it ranges anywhere from 2,048 cores down to 112 cores. It's network attached storage, it's PMIM, it's a mix of PMIM and NVMe, right? So there is a variety of different hardware configurations that KX has been deployed to here. And this is the Kanaga one, very similar, but you can see it's dominated by PMIM. So let's remove Optane from the equation. I went through every result that's ever been submitted and removed Optane. The numbers stay the same. 15 of the 17 Antuco records are held by KDB Plus. But you'll see that some of them are even held by KDB Plus like 3.5 and 3.6, right? KDB has been performant for a while, and SUTs with 4.0 haven't surpassed them yet. And in Antuco, it's the same. They have they're the database of choice. I want to be clear, as much as the folks from KX here today would like me to say, KX has the record. I can't. It's the system under test has the record. Our tests don't just test the database. They test everything in the system. But the people that set those systems up, and this is not KX that set these systems up. They might have helped in getting KDB installed. But these are different hardware providers that wanted to show their systems. Chose KDB to get to this point. Now I have a little time left. It's not stack if we're not measuring, so I've got my own timer up here. I was asked to talk about possible future new trends. And I wrote some down because it's what I'm hearing. And these aren't just trends that I'm making up. These are from talking to many, many, many financial firms. I did have to be careful here. If it's something a financial firm disclosed and didn't disclose it publicly, I did not include it. But these are things that have come up in working group conversations at STAC events, things that I'm hearing from requests that vendors and financial firms have made for new benchmarking, et cetera. And of course, because it's me, I wrote this all down, and then I was driving here today from JFK and thought, oh, I missed a couple of very important trends. So I'll just talk about those without slides. So a possible future is more hybrid cloud and on-prem. This is one that I thought I didn't have a slide for. This is great. Many other industries moved to cloud way in the past. Being a member of financial services and being a technologist in the FSI world for 2 decades, I feel like I can be self-critical. And in FSI, we love to think we're special and on the bleeding edge of everything, and we're not. We missed the boat on cloud. An interesting discussion is, did we get into cloud so late that we can no longer influence it for what we actually want? And that's something I'm happy to discuss at any time because it's been nagging at me lately. But during COVID, what we saw is many financial firms could not source the equipment that they needed in order to process the data as volatility increased. I got 5, right? 2? I've got 24 minutes so far. Okay, well, we'll go fast. what they did was, so instead they made it the cloud provider's problem. So they're moving more and more to the cloud. And data analytics was first forklifted. Now it's being more optimized. And what we're going to talk about in just a second is how it's actually merging with on-prem more and more. And that's actually the interesting trend I see coming. The object store utilization is another trend. In fact, we're getting asked by many, many financial firms to start having STAC-M3 benchmarks on object store. So we've been going to the vendors and saying, hey, we should have more STAC-M3 benchmarks on object store. People want that. And it's because we're seeing more and more people move from object store being used as a cheap way to store data. What is it, like 90% of financial data is write once, read never. But for the times that it's write once, read many, we're starting to see them actually read directly from object store rather than save it in object store and then load it into file system when they want to use it. They're just going straight to object store now. So there is some STAC-M3 work going on that right now. We don't have to change the queries. We do have to change the data a little because compression is big in object store, and our data is not as compressible as real NICE TAC data. KX has been supporting this. I don't think Faronk is here, but he has been helping a good deal on comparing our randomly generated data sets to NICE TAC data sets to make sure they're as compressed as possible or as alike as possible in compressibility. That was the end of the slides I had, but I do want to go into one really important future use case that we've been seeing. And I missed yesterday's announcement, got filled in today, and it kind of overlaps with that use case, with this use case. So those three different architectures we had before, there's the set data load, or the three different use cases. Set data load, ad hoc, what the hell? What we're seeing is what the hell is on-prem. It almost necessarily has to be because you're ingesting that data and you got to look at what happened 30 seconds ago. You're not talking nanoseconds or microseconds. It's boss time. I have to know the answer before the guy behind me slaps me in the back of the head. So that's on-prem. And what we're seeing is people are running those more and more and they're saying, okay, I know what the heck just happened, but is it going to happen again? It just happened in this equity. Is it going to happen in other equities? Have I seen this pattern before? Is it indicative of something else? So they're finding that, the what the heck just happened, and then running more and more ad hoc queries in kind of a walled garden so that they can figure out exactly what the pattern is. And then they need to see, did I see this 6 months ago? Did I see it a year ago? Have I seen it 300 times in the last year and I just didn't catch the short end of the stick and lose money? Like, is this something I can take advantage of? And they want to get that information rapidly. Should I pull my trade from the market? Should I scale my trade up? Should I change the risk profile? And so what they're doing now, or what they're interested in doing, I haven't actually seen anybody tell me they're doing this yet, but what I've seen a lot of interest in is, all right, I figured out what the heck just happened. I've run enough ad hoc queries to know what that pattern looks like. I now want to deploy this, and I need to deploy it in a way where I can research over X amount of years, but I also want to do that without being a noisy neighbor stepping on that already set workload I knew I was running that I've already given enough resources to. And so they're starting to look at automatically spinning up into the cloud. So they're taking their on-prem queries and they want to then be able to define, I need access to this data in a performant way over this amount of time, and here's the queries I want you to run, and just return back to me when you're done, how many times have I seen this pattern? So it's a hybrid cloud approach, but it's not necessarily because they want to do hybrid cloud. It's because they have a hybrid workload approach that they're mixing together, and that's necessitating being on-prem and in the cloud. And I was told I had 2 minutes, 4.5 minutes ago. So I'm now over my time. If you've ever come to a STAC event, you all would have stood up and warmly applauded me off the stage so I couldn't talk anymore. But that's my talk. We're probably out of time for questions. But if anybody has any, I will be here, and I'm happy to talk to you. Thank you.